everyone, and welcome back to Life Technologies YouTube channel. I hope you're doing well, and thank you so much for watching this session. So this is another episode of our Juniper Lab simulation series, and in this session we'll be discussing how to implement BGP route reflection on Juniper MX devices. So we know that BGP is a very common networking protocols deployed almost on all service provider networks across the world, and we normally call it the protocol of the internet because of its capacity to handle many routes and the flexibility to control how you want the traffic to flow using the BGP path attributes. So when you have BGP running, you will need to configure the BGP peering session between routers. And we know that BGP has the principle of split horizon to help us to control loops or to prevent loops in a network that is running BGP. So what split horizon does is if you receive a route from an IBGP peer, you don't advertise it to other IBGP peers. So for this case, if we have a route that is being advertised from R2 and this route is advertised to RR, which will be our route reflector once we complete the configuration, the RR will not advertise the route to other peers because this is an autonomous system. The routes are in the same AS number. So the route will not be advertised to anyone else. So we need to find a mechanism to solve this issue. There are multiple options. You can use the route reflection, which is the most common solution. You can use meshed peering, which means that every IBGP router will be peering to all the other IBGP routers. But that one is not scalable, especially when you have a big network. Imagine if you are having 100 routers and you need to establish 99 session with all the other routers. So it's not scalable when it comes to the service provider networks. You can also use BGP confederations, which we'll be discussing in the subsequent sessions. So for the service provider networks, we normally prefer to go with route reflection. So with route reflection, we have one router in the network that is in charge of propagating the routes to the other peers. And we can have clients and non-clients. So a client means that this route reflector has the responsibility of advertising all the routes to the clients. He's like a neighbor. He has to receive the routes from the route reflector. And we can have non-clients, which are not part of that cluster if it's for the route reflection. So we have R2. R2 advertises a route to RR. The RR will advertise this route to all the clients in this cluster. And with the BGP split horizon, if we don't implement route reflection, when R2 advertises a route to RR, and this is IBGP peering session, that route will not be advertised to R4. The route will not be advertised to R5. The route will also not be advertised to R3. So you find that we have some disconnect in the network. And remember, when you are setting up the network, you need to have different nodes communicating or different nodes connected to different routers communicating with others within the autonomous system number. So you need to ensure that the routes are propagated across the network to ensure the connectivity between the nodes or among the nodes on your network. So we need to have route reflection functionality so that we have one router that is in charge of propagating the routes across the network. And that's why you need to understand the principle of route reflection, and you also need to master how to implement route reflection on different vendors. We've already demonstrated how to do this on Nokia. We've also demonstrated how to do this on Huawei, and you can check out those recordings on our channel. So with this in place, I will log into the routers and we'll do the configuration step by step. So starting with the basic configuration. So we need to start by doing basic interface configurations on all the routers. So we'll do the host name. We need to do the interface configurations. We configure interface IPs both on the physical and the logical interface. When we establish BGP sessions, we'll be using the loopback IP to establish our BGP peering sessions. So starting with RR1, these are the basic configuration that we need to configure on RR1. So I may need to copy the configuration in bits because some are reporting errors. And then I'll copy the last two lines, the last three. So if you do show pipe compare, you will see that we are configuring the host name and configuring the interface parameters. So I'll do commit. Then we can configure the next router, which is R2. So for R2, we need to set the host name. We need to configure interface gig 00 and gig 001. And for gig 001, this is the interface that we will be advertising to BGP. So we will not be advertising this protocol or this interface into IGP, the OSPF. So we configure it so that we can advertise it through BGP to the other peering sessions. So on R2, I'll just run again so that it picks. I'll do show pipe compare. So you see the interface parameters, then commit. I'll move to R3. And then commit R4. Need to do the configure command. Then I'll commit. Finally, R5. And do commit. So once we've done the basic configurations, we'll go to the next step. And in the next step, we need to configure OSPF. So we need to configure OSPF on the interfaces, activate it on loopback interfaces, configure the router ID. So you see that we are using the loopback interface at the router ID, which is always the best practice. So starting with RR, so we've already demonstrated how to implement OSPF. So I'll not go into details of this implementation. I'll just do commit. On step on R2, we need to do the same. Then we'll verify that our OSPF neighbor relationship is up. On R3, on R4, then on R5, so I'll do commit and then go back to RR, which is connecting to all the other routers. You can run show OSPF neighbor. So you can see that we have two adjacent these already in full. The others are in extant, which means they are still coming up. So we give it some time to be fully established. So 3 are up. We wait for the other one to come up. So it's to router 2, router 3, router 5, router 4 should be coming up very soon. So we have that adjacently coming up. If I show routes, run show routes, you see that we have OSPF routes. I can ping again. We need to use the run command, run ping 2.2.2.2. We are able to reach it. And then 3.3.3, we should be able to reach it. 4.4.4.4 should also be reachable, and then 5.5.5. So it's always good to do these checks before you move to the next step to ensure that you don't implement BGP and then you again troubleshooting IGP. No, you need to confirm that your IGP is okay, and then you can move to the next stage of implementation. So the next step is to implement BGP. So for the BGP configurations, we've already also demonstrated how to implement BGP. So I'll just go through the configurations and run them on the routers. So we are creating peering in a 65,000. This is the local autonomous system number. The type is internal. We are using the loopback IP as the local address. And then we are only peering in the IPv4 unicast. And these are the neighbors. So RR will be peering to all the other R2, R4, R3, and R5. So I'll copy these configurations, go to RR, again show pipe compare. I'll commit. The next router is on R2. So on R2, this is where we have the interface that we need to advertise to OSPF. So that's why you can see that we are creating an export policy, and this export policy is used in BGP. So we've already demonstrated how to use some of these export policies in our previous sessions. And I'll just configure it, and then we can do the verifications. So on R2, the policy direct BGP set policy option policy statement. Is it the last command not taking effect? Then we'll configure the filter so that we specify that we only want to have these prefix. So I'll do commit. Must define local autonomous system number. So that one did not take effect. The local autonomous number is still the same. So sometimes you may miss some commands. You need to be keen when you are preparing your script and cross-check again. So this is on R2. On R3, we need to do the same. So this is R3. Commit. Then R4. Command not picking. So I'll just copy the last few lines. We don't need the inet, so I can remove it. We are only using the inet unicast, not the VPN v4 peering. So I'll commit. Finally, we need to do the configurations on R5. Then I'll do commit. So once we have done the configuration, if I show run BGP summary, we expect that we should be having 4 sessions established. You can see that we have 4 sessions, 1 to R2, R3, R4, and R5. So with BGP split horizon principle, or the mechanism, you can see that on R2 we've advertised this address into BGP. And when you check on RR, if I show route, again it's run show route protocol BGP, you see that we have this route. It has been advertised on this peer. But when you check on R3, run show route protocol BGP, you see that we don't have any route, because from R2 is IBGP with RR. So when R2 advertises the route to RR, RR will not advertise it to anyone else. That is the default BGP behavior of route advertisement. So we need to make it to enable RR to advertise these routes to the other nodes. So that is the goal of this lab, remember? So when you go back to the configurations, and even when you check on the other routers, if you check on R4, show route, run show route protocol BGP, you'll see that we also don't have this route because this is still IBGP. So when you get it from an IBGP neighbor, you don't advertise to any other IBGP neighbor. So what we need to do is to implement route reflection on RR. And the good thing with route reflection is you only need to do configuration on the route reflector. You don't touch on any other devices. You only implement it on the route reflector. And it's very simple to do this on Juniper. You just do it with one line. So you need to set the cluster ID. So once we set the cluster ID, now this router will be the route reflector of this cluster. So I'll go to RR and apply this command, show pipe compare, commit. So now we have this router configured as the route reflector. If you go back to R3, it will take some time before the route is propagated. Go to R4, not yet. R5, you can see that this route is now on R5. Let me check back on R3. So you see that the route has now been installed in R3 and it has been advertised from. So if I do extensive, you see that the route is coming from 1.1.1.1. But the next hop, remember with IBGP, we don't change the next hop. So the next hop is still 2.2.2, which is the originator of that route. Even from the originator ID, you can see this parameter, and you can see that this route is coming with the cluster ID. On R4, you also expect that we now have the route. If you do extensive, same parameters, you see the next hop is the loopback IP of R2. And then we have the cluster list and the originator ID. On R5, if you do extensive, we also have the same. If you run show route, we expect to be having that route. This is .8 and you see that it's coming from BGP and it's advertised from 1.1.1.1. So you see that our route reflection is working okay with just one command. You configure the cluster ID. Remember, when you have multiple route reflectors, this cluster ID also plays a very important role, which we'll discuss in our upcoming sessions. So what if you don't want some other routers to be clients to this route reflector? So you don't want them to be clients to the route reflector that we've set. Maybe you don't want these, they will be non-clients in this case. So what we do is we can use these commands to disable the route reflection towards specific clients. So for example, I want to disable route reflection towards R3 and R5. So I need to set protocols BGP group IBGP, this neighbor, no client, reflect. So I'll go back to RR and you can see that we are still doing the configuration on the RR. We haven't touched any other routers. We only need to do the configuration on the route reflector. So it makes it easy. You can manage the route reflection from the central point, which is the route reflector. So we've disabled route reflection. They will not be clients anymore to this RR. So when I go back to R3 and run show route BGP, you see that that route has disappeared. Now it's not being advertised because it's coming from the client. If it comes to the client, it will only be advertised to the client. But if it's coming from non-client, then it will be advertised to both non-clients and the clients. So you see that we've disabled the route reflection functionality on this router, and this route will not be propagated towards the non-clients. So this is it. This is how simple it is to implement route reflection. And again, just one command will be able to achieve that functionality. And you only do this configuration on the route reflector. If you want to disable route reflection functionality towards some other peers, you use this command. You set protocols BGP, the neighbor, and then you specify the neighbor IP and the no client reflect command will do that for you. So this is it for this lab. We've demonstrated to you how to implement route reflection on Juniper MX devices. I hope you've enjoyed the session. And just a kind reminder that if you are watching this session and you are yet to subscribe to our channel, kindly support us by subscribing to this channel. Also remember to like, comment, and share with your connections. Also remember to check out other tutorials on this channel. Thank you so much and see you in the next episode.